right, so here we're going to be talking about the physical properties of amines. It's going to be really important for you to be able to identify whether they're primary, secondary, or tertiary, because that's going to have a huge impact on the way they behave. Okay, so your amines that are primary and secondary, these are going to have weak hydrogen bonds. Remember in the previous video, I drew the lone pairs on all of the amines, almost all of them. And this is why. So that nitrogen has that lone pair. It has the ability to be a hydrogen bond acceptor, and the hydrogen has the ability to be a hydrogen bond donator. If you remember back to 1201, we talked about hydrogen bonding. The hydrogen bonding exists between when a hydrogen is bonded to an oxygen, which we've already talked about, but also when a hydrogen is bonded to a nitrogen. So this is where this comes into play. So for both the primary and the secondary, both of them have a hydrogen bonded to the nitrogen, which allows them to experience hydrogen bonding. And again, that lone pair in the nitrogen is going to be your hydrogen bond acceptor. Your hydrogen is your hydrogen bond donator. Another thing I wanted to point out is that if we pull up mole view for both of these compounds, you can see very distinct red and blue areas. So the nitrogen is going to be slightly positive, the hydrogen is going to be slightly negative. But this is a relatively large difference in electronegativity, which is why you see such dramatic colors when we pull up mole view. So again, the takeaway is primary and secondary amines are going to have weak hydrogen bonding. Okay, so now on to our tertiary amines. So tertiary amines, notice that there is no hydrogen directly bonded to the nitrogen. So this means that tertiary amines do not have hydrogen bonding, but they do have dipole-dipole interactions. And so again, that nitrogen is going to be slightly negative, the rest of the molecule slightly positive, and so you do have interactions or attractive forces between them. Pulling up mole view, you can see that that color variation is not anywhere near as dramatic, and that yes, the nitrogen is still slightly negative, and then you can see the rest of the molecule is slightly positive, but again, it's not nearly as dramatic, and so this is going to have an impact on its solubility, on its phase change, and all of those things. Okay, so here we're going to talk about solubility and phase change. So in the first couple slides, we saw that the primary and secondary amines are going to engage in hydrogen bonding, and that your tertiary amines are not, right? Those have dipole-dipole interactions. However, all three of them can accept a hydrogen bond. Remember, you've got that lone pair on the nitrogen. This means that our amine is going to act as a weak base. It can accept a proton from water, and so this is going to allow it to ionize. This goes back to our discussion from 1201 about acid-base behavior. Now, because it is a weak base, it is going to exist at equilibrium. But notice that when it accepts that hydrogen, it becomes charged. It becomes an ion. Actually, it forms two ions, and it forms an ammonium ion, and it forms a hydroxide ion. This is going to make it very soluble in water. Okay. We are going to see these types of reactions again. When we're talking phase change, so hydrocarbons are going to have our lowest melting and boiling points, then ethers, then aldehydes and ketones. Then we see amines, and this is because they have weak hydrogen bonding or dipole-dipole interactions, and then your alcohols are going to have the highest melting and boiling points, and that's because they have very strong hydrogen bonding.